All right. Good morning. Okay, today we will be discussing the last topic in our chapter, complex numbers. So this topic is the application of complex numbers. So under the application of complex numbers, we will discuss the distance of 2 points. We will also substitute the cosine law with complex numbers. Of course, we will solve the resultant of forces under physics and the relative velocity. So under electric circuits, we will be solving Ohm's law and current divider law, KCL, or voltage divider law, or your KVL, and so on. Now, we will start our topic by reviewing the distance of 2 points. Now, in your pre-calculus subject, you have discussed the distance of 2 points. If you can still recall, this is your Cartesian plane. Now, in your Cartesian plane, that is labeled by x-axis and your y-axis. And your point P1 here is labeled as x1 and y1. Another point, let's say P2, we will label this as x2 and y2. Now, in your pre-calculus subject, you have learned how to solve the distance between 2 points. And that is, the distance of 2 points is equal to the square root of y2 minus y1, quantity squared, plus x2 minus x1, quantity squared. This is how you calculate the distance of 2 points, in your pre-calculus subject. Now, if I'm going to convert this Cartesian plane to its equivalent Argand diagram, now this is your Argand diagram. Now, instead of writing P sub 1, I will write Z1, and then that is equal to the point x1 plus j y1. Take note, the x-axis in your Cartesian plane is equivalent to your real axis in your Argand diagram. And your y-axis in your Cartesian plane is denoted by imaginary axis in your Argand diagram. Now, to represent point 2, I will label this as Z2, that is equivalent to x2 plus jy2. Now, in your lesson 1, the basics of complex numbers, we know, from this point, from this origin up to this point, we know that this is the line segment, Z1. And also, from this point up to Z2, we can solve for the difference between Z2 and Z1. Now, in your previous topic, the distance between this point, we will label that as D, the distance between that point is simply the magnitude or the absolute value of Z2 minus Z1. Now, that was explained in your first topic. Z2 minus Z1 is actually a complex number. So, the distance is actually the magnitude of your complex, or the difference between your complex numbers. Now, we have discussed this in our first lesson. Try to go back to your first lesson and try to review the distance. Take note, this is the distance between 2 points. And the 2 bars here is actually your absolute value sign. Absolute value sign refers to the magnitude of the difference between Z2 and Z1. Now, let's have an example here. Example. Okay, we are going to find the distance between the points 1, 5 and 6, 2. So we are going to find the distance between these 2 points. Start your solution by sketching the distance in your Argand diagram. This is your real axis, and this will be your imaginary axis. Now for the first point, that is 1 and 5, this is 1 and 5. Okay, this is, let's label this as your Z2, that is equivalent to 1 plus J5. Now for the next point, that is 6 and 2, let's label this as 6, and this will be your 2. So 6 and 2 is somewhere here. So we can label this as your Z1, that is equivalent to 6 plus J2. Now, if we are going to solve for the distance of these 2 points, now we need a calculator, of course. So the distance of 2 points is just the absolute value of your Z2 minus your Z1. Now take out your calculator and try to solve this. Your absolute value, take note, your Z2 is 1 plus J5 minus your Z1, which is 6 plus J2. Now in your calculator, you have to put your calculator in complex mode. Can you see there? That is a complex mode calculator, and we will be using, okay, take note, that is a complex mode calculator. We will be using degree mode in this topic. Okay, for if you are referring to angles in the applications of complex number, now we use degree mode. Okay, now that is why you can see there that is a complex mode and the angle is in degree mode. Now try to set up your calculator. Go to setup, because I want your calculator, the output of your calculator, to be in the default polar form, because most of your calculator, the default of complex numbers equivalent is in rectangular form. Now we will set up your calculator so that each time we evaluate your complex numbers, the result will be in polar form. So try to go to setup, that is shift, setup, and then arrow keys, down arrow, and look for the complex number. So that is 3. So press 3, okay, select complex numbers, and what will be the result? Now we will select number 2 because we want the result to be in polar form. So select 2. Okay, now every time you answer every time you simplify complex numbers, the result will be in polar form. Now let's go back to the problem. Now we will solve the absolute value of 1 plus J5 minus 6 plus J2. Now in your calculator, I'm sorry, my calculator is not that good anymore. I'll try to focus well on the problem. Anyway, all you have to do here is to find the absolute value. So the absolute value is here. So you have to press shift and the absolute value. So let's try now. Shift, absolute value. Now that will be the symbol for your absolute value, and insert 1 plus J5. Now you cannot use that one. In your calculator, you write the number first, followed by I, minus 6. Now this is 6 plus J2. So that in that case, that will be 2I. So press equal sign. The absolute value will give you the magnitude. That is the magnitude of the distance between 2 points. So the magnitude is 5.83. So this is 5.83. Take note of that. You can use this in your board examination. This is the shortcut key, the shortcut now on how to solve for the distance between 2 points. Now, let's go back to our topic under cosine law. So we have cosine law. Can you still recall your cosine law that is under your trigonometry? In your trigonometry, if you have a triangle here and the sides A, let's say B and C, and the angle here is equal to theta. Now to solve for C, no, we need an equation under your cosine law. If you can still recall your to solve for C, in your cosine law, no, C squared here is the sum of the squares, no, of the other side, that is A squared plus B squared minus 2 times AB multiplied by the cosine of the opposite angle of your C, that is theta. Now to solve for C, no, you are going to take the square root of both sides, that is A squared plus B squared minus 2AB cosine of theta. That is using the cosine law to solve for the variable C in your triangle. Now, for this topic, now I will teach you how to solve the value of C without memorizing any of these formulas. Okay, let's start with by drawing your Argand diagram. So this is my Argand diagram, and I will represent this triangle in my Argand diagram. Now I will draw this side A along your real axis. This is my side A. Of course, no, this will be my side B. And the angle between A and B now is denoted by theta. Now, what is missing here is the side C, and we are looking for that side. We will be solving for that side using the complex number. Now, since we have now plotted the triangle in your Argand diagram, we will label the points here in terms of the polar representation. So in this case, the point here is represented by A, because A here is the magnitude of, is the length of this side. So you can represent that as A angle of 0, because this is along your real axis. Now to represent this point, we can label this as B angle of, take note, the angle here is theta. Now, if we will label this point as your Z1 and this is Z2, Z1 is equals to A angle of 0 and Z2 is equal to B angle of theta. Now, to solve for the distance C, that is simply Z2 minus Z1, or to find the magnitude, that is simply the magnitude of Z2 minus Z1. That is using your complex number. This is much better than the cosine law. Let's try to solve one problem here. So example, if I have the triangle, okay, given this triangle, okay, this is my triangle. Okay, I will label this triangle as 40. This is in meters, and 20. This is in meters, and the angle between the sides now is equal to 30 degrees. Now we are looking for the value of x here. Okay, let us solve for x. Now, let's solve for x now in this problem. So what will be your solution here? Your solution is to draw the triangle in your Argand diagram axis. In this case, now I will draw this side along your real axis. This is my real axis and this is my imaginary axis. So real axis, that's 40 meters. Now I will remove the unit now, and I will put the unit later on for the final answer. So this is 40, and I will label this as your Z1, which is equals to 40 angle of 0 degrees. Now, another side, okay, I will label this as 20, or to represent that in complex form, that is 20 angle of, take note, the angle between the sides is equal to 30 degrees. So this will become 20 angle of 30 degrees. Now, to solve for the value of x here, that is just the magnitude of the difference between the two complex number. So this is now equal to 20 angle of 30 degrees minus 40 angle of 0 degrees. Take out your calculator and solve this one. So again, this is the absolute value of 20 angle of 30 minus we have 40 angle of 0. Okay, press equal sign. You have 24.79 as your magnitude or the value of x, that is 24.79 meters. So that's how easy now to solve this problem using a complex number. Any questions? Now try to type your questions now in our chat group now for clarifications. Okay, that is cosine law. Now we go to forces and relative velocity. So this will be our next topic. Oh, I'm sorry. No, I have to find another ball pen. Okay. Forces and velocity. Okay. So first, now we will discuss how to find the resultant of the forces. So going back in your physics subject, if I have here my force F1, okay, I will label this as force F1, and the angle of your force F1 from the x-axis, let's label this as theta 1. Another force, which we will label this as force F2, and from the x-axis, we have theta 2. Now, to solve for the resultant force, we use the parallelogram method. So meaning to say, in your parallelogram method, we draw a parallelogram. Take note, this force F2 will be drawn here in parallel with that your force F2. Now, from your origin, now we will draw the line up to the other end of your parallelogram. And we call this line of force as your resultant force. So I will label that as resultant force. Now, resultant force in your physics can be solved using the summation of the x-axis and the summation of your y-axis, if you can still recall that one. So summation of forces along the x-axis, quantity squared, plus summation of forces along the y-axis squared, and then take out the square root. That's how you calculate the resultant of forces under your physics. Now, in our case, now we will be using the polar form of complex numbers. Now, we will convert this axis into the Argand diagram. Now, in the Argand diagram, you have here your real axis and your imaginary axis. Now, I will redraw these forces. In this case, now I will name this force as Z1, and I will label this as F of 1 because that's the name of your force, angle of theta 1 because that is the angle from your x-axis. Okay, now for your second force, I will label this as Z2, that is F of 2, angle of theta 2. Okay, now if you are going to recall your previous topic in your basics of complex numbers, we solve the difference between two complex number, that is Z2 minus Z1. So the difference of two complex numbers is actually solving the distance between 2 points. Now, if you are going to add the two complex numbers, it will result to the resultant force. So the resultant force is the sum of two complex numbers. So in this case, the resultant force is the sum of two complex numbers. So that is Z2 plus Z1. Okay, now the resultant force now is Z2 plus Z1. I remove the absolute value sign in order for us to know the angle of the resultant force or the direction of the resultant force. So in this case, this will become F of 2 angle of theta plus F of 1 angle of theta. Now, if you are looking for the magnitude only, you can put the absolute value here. No, if you are looking for the magnitude only. But no, if you are looking for both the magnitude and the direction of force, now you have to remove the absolute value sign. So this is now your equation or your formula for your resultant force. Now let's have an example here. So for our example, we are going to find the resultant of the forces below. Forces shown below. I have here my forces drawn in a polar coordinate system. So I have here 20 Newton that's going on that direction with an angle of 30 degrees. Another force, let's label this as your F1. Another force, now we will label this as our F of 2. So I will make it 10 Newton. Okay, by the way, now we will put the unit after the angle. So this is 20 angle of 30 degrees Newton. So in this case, this is 10 angle of, let's say, this is 100 degrees Newton. And the last force we have F of 3. This time we will label that as 15. Let's say 15 angle of, from this up to that point, that is 170 degrees Newton. Now your goal is to find the resultant force. Now, how are you going to do that? So the resultant force is simply the sum of all the polar forms of the forces present there. So your solution will be the sum. This is your resultant force is just equal to the sum like f1 plus f2 plus f3. Now, try to solve this in your calculator and we will compare our result. Okay. Get your calculator and try to solve the function. Try to solve the resultant force here. Okay, I will be solving here my resultant force. Okay, I will have my F1 to be 20 angle of 30 degrees. Take note, no, this is in mode degree because in this section, in this topic, now we will be using degree as the way to represent our angle. So we have force F2 that is 10 angle of 100 plus we have 15 angle of 170. So take note, I remove the absolute value sign and my final answer would be 22.47. That's 22.47 angle of, okay, ROK, angle of 87.93. So we have 87.93 Newton. So this is my resultant force. I hope my answer is the same as yours. Okay. This is to see to it that you are following my discussion. Sometimes now I put a wrong answer on purpose. All right. Now we go to the relative velocity. So I have here the relative velocity. Okay, relative velocity. Okay, relative velocity. Now, if I have here a car that is going on this direction, okay, with a velocity of a, let's say the velocity of this car is a, and the angle here, let's label this as x and y, and the angle here is theta a. Let's label that as theta a. Now another car going on this direction, okay, I will draw the car. I'm not good in sketching the car. Okay, going on this direction, and having a velocity of v, and an angle of theta b from your x-axis. Take note, the angle here should be from your x-axis. Now, if you will encounter some problems that the angle is designated here, now you have to solve for the angle from the x-axis. All right. Now, the relative velocity of the car can be solved using their difference. So the relative velocity of b to a from a, this is how you write it. The relative velocity of b from a, now that is b, a velocity of b over a, or the relative velocity of a from b, relative velocity of a from b, that's how you write it, is simply the difference between the velocities in complex form. Now, if we will label this car A velocity as, okay, instead of VA, I will use ZA. If I am going to label this as ZA, that represent the complex number of the velocity of this car A, that is VA angle of theta A, and I will label this as ZB, that represents the velocity of this car with an angle of B. So therefore, the relative velocity, this is just the same. If we are looking for the magnitude, is the magnitude of your ZB minus your ZA. Take note, if you are solving for ZB minus ZA, We are actually looking for the relative velocity of B from A. Now, if you are looking for the relative velocity of A from B, this is minus ZB. But for magnitude, they have the same result. Now, let's try this problem. Okay, I have a problem here. So, example, this is a long worded problem. So I will try to write it clearly. So, a car with a constant velocity of 80 kilometers per hour is heading north. Okay. A train with a constant velocity is heading northeast. Okay. A boy inside the car noticed the speed of the train is slow. Now we are going to solve what is the relative velocity of the train from the car. Okay, so that's a long problem solving, but the solution here is not that long. So you are going to solve the problem first by representing the velocities of the car and the train in your Argand diagram. Now, first, we will plot the velocity of the car. The velocity of the car heading north. So this is the car heading north. I will label that as Z. Okay, ZA. So the velocity of the car is 80 kilometers per hour. That is 80 angle of, since it is heading north, the angle there is 90 degrees. So so a train going on this direction, northeast, take note this is east and this is your north, going in this direction, the angle here is 45 degrees. Now I will label it as say B, and the velocity of the train is 100. Did I put the velocity here? With a constant velocity of, of 100 kilometers per hour. Okay. So this is 100 angle of, since that is headed to northeast, the angle is 45 degrees. Now we are looking for the relative velocity. So the relative velocity of the train, that is ZB, from your car is denoted by ZBA, is equals to the absolute value of 100 angle of 45 minus 80 angle of 90 degrees. Okay, now I want you to solve that in your calculator. Okay, we'll try to solve this in my calculator also. Okay, I have here the absolute value. Absolute value of 100 angle of 45 minus 80 angle of 90 degrees. Okay, did I type it right? Oh yes. Now press enter. Oh, error because of this sign. So equals. Okay, this is the relative velocity, that is 71.32. So the relative velocity is actually slower, as now seen by the boy. That is why the boy noticed that the train is slow, because of the relative velocity. Since the train is moving and also the car is moving, of course the relative velocity will become slower. Okay, that is 71.31 kilometers per hour.